Hello students, today we are going to discuss some questions related to hybridization. So hybridization there are simple tricks are there how to find out hybridization of central element and all those things we are going to discuss in detail. Students, today we are so simple. Let me explain simple trick how to identify hybridization. So in a question, first question, in this first question, in which of the following molecule the central atom is not sp3 hybridization? They are asking. Which of the following molecule is central atom is not sp3 hybridized? So to identify hybridization, there is a simple trick is there that you select whatever the atom given here that you select. In that central atom is phosphorus. Phosphorus is having how many valence electrons? 5 valence electrons. That is, so you write 5 valence electrons. 1, 2, 3, 4 and 5. Okay. Then after chlorine, how many chlorines are there? 5 chlorines are there. 5 chlorines will form sigma bond. 1, 2, 3, 4 and 5. 5 chlorines. Each single bond is sigma bond. 1 sigma bond, 2 sigma bond, 3 sigma bond, 4 sigma bond, 5 sigma bond. So you remember this thing, if 2 sigma bonds are there, that is sp hybridization. If 3 sigma bonds are there, that is sp2 hybridization. If 4 sigma bonds are there, that is sp3 hybridization. If 5 sigma bonds are there, that is sp3d hybridization. If 6 sigma bonds are there, that is sp3d2 hybridization. sp3d2. So now here how many sigma bonds are there? 1, 2, 3, 4, 5. 5 sigma bonds means that is sp3d hybridization. So they are asking in which of the following molecule is central atom is not sp3d hybridization. So this is not our answer because it is having sp3d. Which one is not, they are asking which one is not. Then you go for ClF3. Chlorine. How many valence electrons are there in chlorine? There are 7 valence electrons are there in chlorine. 7. So that is, so 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. So 3 fluorines are there. So each fluorine will form one bond. That is 1 bond, 2 bond and 3 bonds. Here 4 unpaired electrons are there. So 2 electrons will become 1 sigma. 1 lone pair of electron, 1 sigma bond, 2 sigma bond. 1 sigma, 2 sigma, 3 sigma, 4 sigma, 5 sigma. Means this is also sp3d hybridization. So this is also not our answer. This is also not our answer. SeF6. You go for SeF6, selenium. Selenium, oxygen, sulfur, selenium, tellurium. So means this is 16th group element. So how many electrons it has? Valence electrons, if you don't know, then you go for first element. 1s2, 2s2, 2p4. Right? So how many valence electrons are there? 6. So you take 6 valence electrons. Selenium is having 6 valence electrons. 1, 2, 3, 4, 5, 6. How many fluorines are there here? 6 fluorines are there. 1, 2, 3, 4, 5, 6. Fluorine can form single bond. So you connect like this. If oxygen is there, you have to connect 2 electrons. How many sigma bonds are there? 1 sigma, 2 sigma, 3 sigma, 4 sigma, 5 sigma, 6 sigma. 6 sigma is there, which hybridization? sp3d3. So this is also not our answer. Then XeF2, xenon difluoride. Xenon is having how many electrons? So this is only answer, sorry. CF6 only answer. This is not multi-correct, single correct, so that's why this is answer. Selenium hexafluoride. Which one is not sp3d they are asking. This is PCl5 sp3d, ClF3 sp3d. Then we'll check this also, our doubt will get clear. So xenon. Xenon is having how many valence electrons? So 8 valence electrons. That is 1, 2, 3, 4, 5, 6, 7 and 8 valence electrons are there. So I told you already fluorine can form single bond. So you join 1 fluorine, 2 fluorine, 3 fluorine, sorry 2 fluorines only, 1 sigma bond, 2 sigma bond, 2 electrons will become 1 sigma bond, 2 sigma bond, 3 sigma bond. Total how many sigma bonds are there? 1 sigma, 2 sigma, 3 sigma, 4 sigma, 5 sigma. 5 sigma bonds are there means that is sp3d hybridization. So this is not having sp3d hybridization, so that option 3 is answer for that. So let me erase this, then you will get easily. Right. So in which of the following molecule the central atom not sp3d hybridization? So answer is this one. So by using this trick you can answer all questions easily related to this hybridization. Second question. Molecule obtained by sp3d2 hybridization has bond angle. sp3d2 hybridization. Which geometry? sp3d2 hybridization means the geometry is octahedral geometry. The geometry is octahedral. In octahedral, what is the bond angle? 90 degrees. Octahedral geometry 90 degrees means the octahedral geometry will be like this. One upside and downside here. So like this it will come. This is called octahedral. Here central element will be there. Bond angle will be 90 degrees. Molecule obtained by sp3d2 hybridization has a bond angle that is 90 degrees. sp3d2 hybridization, that is octahedral geometry, bond angle will be 90 degrees. So answer is this one. The hybrid orbital having equal amount of s and p character. Equal amount of s and p character. So this type of questions how to solve, let me explain. First, how can we decide s and p character, that we'll see. For example, if any compound undergo sp3d sp3 hybridization, then total how many orbitals are there? 4. 1 s orbital and 3 p orbitals, total 4 orbitals are there. Orbitals. Percent is always calculated by 100. 100% divided by 4. Then how much will come? 25. So means each orbital is 25, right? So how many s orbitals are there? 1 means s character is 25. So how many p orbitals are there? 3. So 3 into 25, which is equal to what? 75. So p orbital is 75 and s orbital is 25 in case of sp3. So you check similarly in case of sp hybridization, how many orbitals are there? 2. So 2 means 100 divided by 2 you have to do. Then how much you will get? 50% s orbital and 50% p orbital. 50% will come. S orbital is 50% as well as p orbital also 50%. So which one is answer? Option 1 is answer. SP. Next one. Hybrid orbitals having maximum p character. Maximum p character means, so in case of sp3d hybridization, how many orbitals are there? 1, 3, 4, 5 orbitals are there. 100 divided by 5 means each orbital will get 20 20. So that how much it is? 20 into 5. 20 into 3 means this you will get 60. So in this how much? 75. In this how much? 50. In this how much? sp3. This will be not answer because here p3d2. Total 7 orbitals will come. 6 orbitals will come. 100 divided by 6 you do, 16 you will get. So answer is the sp3 hybridization. I hope the answer is clear for this. Go for question number 78. Molecule having sp2 hybrid atom in it is BeCl2. Beryllium is how many? Beryllium is having how many electrons? 2. 1, 2. 1s2, 2s2, no electronic configuration. How many valence electrons are? 2. 2 valence electron. 1 chlorine, 2 chlorine. So this is sp hybridization. Carbon dioxide also sp hybridization. So this one, formaldehyde. In formaldehyde, this carbonyl carbon is having what? sp hybridization. In formaldehyde, this one is having sp hybridization because 1 sigma 1, 2 sigma 1, 3. So sp2 hybridization, like that. In ammonia, next question. In ammonia, NH bond ammonia molecule. In ammonia, nitrogen will undergo sp3 hybridization. It will have structure like this. So this is sp3 hybridization and this is S. So the bond is sp3s. Sigma bond is sp3s. Sigma bond is sigma sp3s present in which orbital? Just now we discussed ammonia. The type of overlapping in BRF. The type of overlapping in BRF bond in BRF3 molecule. So Br, how many electrons are there? Br, 7 electrons are there. So 1, 2, 3, 4, 5, 6, 7. F3 fluorine, 1 fluorine, 2 fluorine, 3 fluorine, 1, 2 and 3. Then how many electrons remain? So this one sigma bond and 2 sigma bond, 1, 2, 3, 4, 5. 5 sigma bonds means that is sp3d hybridization. sp3dp overlapping, this one sp3dp. Hybridization involves combination of redistribution of atomic orbitals. So this one will come option 2. So I hope these questions are clear. I think so. In next video I will come with other questions. Thank you. Have a nice day.